today I practiced a little bit that subqueries kind of thing, but it looks, I mean, it seems similar to the join, but we don't use join, but we use aliases. It sounds like a joiner as well, so it makes me kind of confused with joins and these, but uh, yeah, I got idea.
Okay. Yeah, for the subquery, did you solve the answers like questions from the joins? Yeah, like
Yeah, I didn't
what is
complete
it?
all. I did some of the problems, so I think most probably I will complete it by tomorrow.
Okay, yeah. Just try to solve whenever you get the time. You'll
Yeah.
get an idea. Okay, let's say this is what we are having here. Okay, this is an employee data table. Let's say you want to display the maximum of salary, minimum of salary, average of salary, sum of salary. Okay, you can
Mhm.
do that using aggregate functions, right? As well as let's say you want for particular the minimum salary. Okay, so you can write like minimum of salary from this table name. Okay, so you will get the minimum salary. Same way you can get max salary, you can get average, you can get sum. Okay, and this will give you a single value like a scalar value,
Mhm.
right? The output will be the aggregated result. Okay, but if you want to display the corresponding employee as well, who is having this, what is that? Salary here. So what is that column name? The employee name is a column, right?
Mhm.
Okay, so if you want employee name along with the minimum salary of that employee, so what you can do is you have to write the group by clause here, right? So in that case, we will get the employee name and like minimum salary, but this will give you a separate result because there are no duplicate employees we are having. So group by is required to have the multiple records that can be grouped together, right? So here we are
Mhm.
grouping with the employee name, but there is only one employee per employee name, like unique employee names we are having here.
Oh,
So
okay.
we'll be
So
getting
instead
a
of name,
single record for each of it, right?
if we have same name employee, so it's gonna give us the identical, the unique value, the employee only. So the employee
Right.
is the
That is
best
good.
if we want all the employees minimum salary, but group by employee ID, right? Did you get my point?
So what we are talking is here, yeah, we have the unique employee names. So even if we group by the result, we will not be getting the correct result. What I wanted to display is I want to display all the employees along with their salary. Okay.
Mm-hmm.
And in front of every employee's salary, there should be one more column which is having the minimum salary. So what is the minimum salary in the organization we are having? That information I need to display out here.
Mm.
Okay. So 45,000 is the salary we are having. So what I want is I want to see this is the data.
Mm-hmm.
Let's say I'm copying it into the Excel file. Okay, so this is the data we are having. And in front of this, I have to add one more column called minimum of salary. And we know what is the minimum salary. We are having minimum salary as a 45,000. So this value I need to display here in each of the column,
Mm-hmm.
sorry, each of the row against the employees. So we can compare like what is the minimum salary we are having in the organization and each employee is having what is the salary. So it will be easier for comparison. Even we can have the average salary, maximum salary, okay, or total salary, sum of salary, anything we can have. Okay. So
Mhm.
whether it is possible to display result set like this, all columns plus additional column with aggregated value.
Yeah, I think yes, we need to derive the next column, that minimum salary.
Okay, so without window functions, it becomes difficult or requires the subqueries. We can write, but we may need some additional subqueries and all. Okay, so that work will be quietly like writing the complex queries. Okay, so we have
Mm-hmm.
to write some complex queries out there, which will make
Mm-hmm.
you difficult to write your code. Maybe some multiple subqueries and all you need to write it. Okay,
Mm-hmm.
but window functions will make this easy. Okay,
Mm-hmm.
so window functions, what it will do, it will perform a calculation across set of data. So this is set of data. So it will perform the calculation like calculating the average. Okay, so whatever the entire set of data we are having, 114 records. So within this set of data, window functions will perform this calculation, okay, across a set of rows while still returning the individual rows as well. Okay, so it will return the individual rows along with the calculated row across the data set. Okay, it does not require or it does not reduce any rows into the result set. But if you write the group by clause or maybe group by clause along with the aggregate functions and all, it will reduce the number of rows because group by what it will do is it will group the results together and it will like limit your result set. So if you group by department, there will be only one row per department, right? If you
Mm-hmm.
group by department, there will be only one row per department and minimum salary in the department, right? Department and average salary in the department. So group by will group the result together and it will return the uh, like common rows or we can say the unique records from the table. But that is not case with the window functions. Window function will perform the calculation across a set of rows, okay, while
Mm-hmm.
still it will return the individual rows as well. Okay, so I'll just show you one example here. If let's say you want to see the department and average salary, okay, department and average salary, what it will do, you write here department ID as a column name, I think. Yeah,
Mm-hmm.
department ID.
Mm-hmm.
Department ID and you write the average salary. Group by again, department ID. So you will get only unique departments. One, two, three, four.
Mm-hmm.
Okay, and this is the average salary you will be getting here. Okay, but let's say what we want is we want to display this average salary along with the original salary as well. So like I want this department ID, then salary,
Mm-hmm.
and then minimum salary.
Mm-hmm.
So this it is not possible to display because you need to add the this column as well in the group by clause, and that will not give the correct result because if you add this into the group by clause, the minimum salary will not be correct, or we can say I will say average salary. Average salary will not be correct within the department only because the partition you will be making based on two columns, like grouping you will be making based on two columns, department ID and salary. So it will not give you the average salary within that department. So that will be an issue. So you see here, department ID 1 is having average salary. I will just use this here, average salary. So we will get the correct. Okay. So we are having this department ID 1 as average salary 63500, 69400. But if you use this one, you will get some different result. I'll just show you. Okay. See here, you will be getting a duplicated record. Yes, because now you are grouping the result by multiple columns and that will create a more groups. Okay, but this can be easily done using aggregate sorry using the window functions. So I will show you what is that window function. So what we
Why
need
it is
is
complicated?
because the group by
It's
is happening with two columns.
so it shows one time with department ID and another time with the salary.
No, it will look for the combination for grouping the
Oh,
data.
okay, okay, okay.
right? So this is the unique, this is unique, this is unique. Okay,
Mm-hmm.
same way for this as well. 45, then 82,000. So grouping will be done by the two columns here. So it will be looking combination to make the unique records. Okay,
Mm-hmm.
and that is the reason we will not get the accurate average salary per department. We will be getting the duplicate records with department ID and salary combination. Okay,
Mm-hmm.
so if you have to display the individual rows along with the average salary, it is not, it is like, it will make little bit complex to create the queries using subqueries and all. But that thing can be easily done using the window functions. Let's say I want department ID, then I want salary. Okay. And then what I want is average salary.
Mm-hmm.
I will write a syntax here. Okay. And then we will talk about this. What is exactly? So partition by department ID. We'll give some name here, average.
Shall
Okay. And from employee data. So this is the syntax for any uh,
window
with
function?
function. So here, see here, department ID 1 is having average 63500, 2 is having 69400. So it will not impact any issues with this. It will calculate the average salary per department. You see here, department ID 1, it is having average salary as 6350. Department ID 2, it is having average salary as 69400. So it is not
Okay.
giving the wrong answers. It is calculating the average salary per department. Okay, along with it, it is returning the individual rows as well. We are seeing here 114 records. So all records we are able to see here. If I add the employee name here, we'll be able to see, okay, this employee working in which department and what is the average salary in that department. Okay, so this particular employee is working in department ID 1. This is his salary, and for the department ID 1, this is the average salary. So we
Okay.
can easily calculate now, we can easily find out the employees who are having more salary than the average salary in their department.
Okay.
Right.
So here, by using window function, what should I understand is we no need to use group by clause, and then the window function is if we use over and partition by that, it's gonna be the window function then.
Right. So over and partition by are the clause that is like not
Clause.
same for all the window functions, but
Oh, one
as
of
in
the.
common, yeah, as in common, window functions, what it is doing is it is calculating the what we how we can define these window functions are the window functions performs the calculation across a set of rows
Mm-hmm.
while still returning every individual row as well. Right. So it is returning the individual rows along with the calculated aggregated values as well.
Wow, okay.
Okay,
So,
that cannot be doable using the simple group by clause, because group by clause will group the rows together and it will return the unique records. Okay,
if
so that is not doable using group by clause.
okay, that's great. So if I want to explain window function, a theoretical question, the what is in window function and what is its business case, how should I explain it?
Right. So what you can say is window functions like these are the what we can say is a window function perform a calculation across a set of rows.
Mm-hmm.
Okay, a window function will perform a calculation across a set of rows while returning the individual rows as well. Okay, or like we can say is like while returning the every individual rows. Okay, so the calculated rows along with the individual row we will get here. It is not only the aggregated rows, we will get individual rows along with the calculated value for those rows.
Okay, if in case I have Ethan Scott at the number one employee, the multiple times, so it will give the unique value Ethan one time or multiple times.
Now all the rows it will give. Okay,
Oh, okay, okay, okay.
yes,
It will give us the duplicate name as well with the
right,
different way. Oh, okay, okay.
right. So yeah, I will talk about these functions now. I have created one of this table called exam results. Okay, and I'm having some sample data out here around 10 or 14 records. Okay,
Mm-hmm.
what this table is having is the data like this. Let's start from. Okay, so we have the data like this. We have the student ID, student name, class we are having. Okay, all students are from 10th grade. Then we are having the subjects. So there are different subjects like mathematics, science, and English. There are three subjects we are having. Okay,
Mm-hmm.
and we are having some marks as well and exam date. Okay, so the marks will be different for each of the subjects and each of the student we are having. Okay, so every student having the information about all the three subjects. So if you see here, Alice Johnson, we can say, okay, there is a typo. So he's having the information about three subjects here. Then second student is having the information about again three subjects, Bob Smith and English. Okay. So we have the information about the student along with the three subject marks. Okay. Now this data set will be using to understand the SQL window functions. Okay. I have one more data set created which is having more number of records. But for initial, we will just take this as an table for our understanding. Okay. So this is the general syntax we are having for the window functions.
Mm-hmm.
We have to use the function name. Okay.
Function name
Then,
means.
yeah, function name in the sense whatever the window functions we are having. We'll be talking
Oh.
about what are all the window functions we are having. So that function name we have to give here. Open
Mm-hmm.
bracket, close bracket. Then over we are having, and in bracket we are having this partition by column name, order by column name. Okay. In that partition by is not a mandatory clause we are having. Okay, order by should be used, but partition by is not mandatory clause. Okay, so with our example, if you see, we have written here, this is a function name.
Mm-hmm.
Okay,
The
then
function name.
over in bracket, we have written partition by clause. Okay, order by is not here. So order by, partition by, these are not mandatory for each and every function. Okay, there will be like sometimes we have partition by, sometimes we have order by, sometimes we have both of these. Where to use partition by clause, where to use order by clause, where to use both. So that details we will see while seeing the examples. Okay, what are those and all. Okay,
Okay.
so this is a general syntax function name over then
Column.
within parentheses partition by column name, order by column name. Okay,
So
and
whatever
these
we
are
have
all
in
the
the parentheses, that's gonna be the optional.
right.
Mm-hmm.
Okay, then these are the different functions we are having. So around nine functions I have written out here, but with a nine, uh, along with this, we are having three more like sum. We are having average, minimum, maximum. Those also can be added as a function. If it is written with over clause, okay, we can call this as a window functions. If it is
Uh,
written only sum, min, max, average without over clause, that is just a normal aggregate functions. Okay,
okay.
but if it is written with over clause, that we call as a advanced SQL functions, or we can say like window functions as well.
Mm-hmm.
Okay, so these functions are very important with respect to the data engineering interview or even normal SQL developer software engineers interview as well, because they will look for the knowledge on these advanced SQL functions. These are advanced SQL functions we call. Okay, these window functions. So make sure you are understanding each of them correctly, and you should be able to write the syntax for each of this. Okay, I will give some exam, like I will give some interview question as well. What kind of questions can be asked on this? Okay, so
Oh,
it will be easy for you.
all right.
The very first we are having is a row number, and it is saying like it will assign a unique sequential number to each row. Okay, so whatever the data we are having in table, it will simply assign a unique sequential number to each of the row. Okay, like let's say we are having this uh, here we are having around 14 records, right, in this table. So it will assign a rank, or we can say unique sequential number to each of this record. Okay, if you add the row number as an SQL window function here. Okay, we will see how it is. The syntax is row number parenthesis over then order by column name. Now this is mandatory thing for this function. Order by clause should be there. Partition by clause is optional. Okay. If you have to use, like if you have to find out the sequential number for each row within specific partition, like based on the department or based on the region, based on the category. Okay, so that we can use the partition by zone. So here in window functions, partition by clause will act as a group by clause.
Oh,
Okay,
okay.
so if you are mentioning partition by, so it is making the partition from the overall records to a specific group of records. Okay, so when we use partition by, it will be making a group of records within the overall, or we can say all the records. But that is an optional. If it is your question or your business requirement is saying to do the partition, then only we have to use. Else, order by clause is only the mandatory clause we are having for all these functions. Okay.
Oh,
Then one is a rank. So rank will assign a rank to the rows. Again, it will also assign a rank. Okay, but if there is a tie, I mean, if there are two records, we are having same salary. Okay, this is, let's say I have run this query. Okay, currently we don't see any records which is having the same salary immediately after following each other, but I will show you with the our data set. This exam result. Okay, so if I run this, it's, let's say I'm using this row number first function, so it will assign a unique sequential number for each of the record. If I'm assigning the rank function, so what it will do is it will assign a rank to each of the record, and wherever there is a tie, wherever there is a like
match like 85 here.
matching value for that particular column, so it will assign the same rank to that record. Okay,
Oh,
and while assigning the next rank value, it will skip the next let's say I'll take this. Okay, and skip the next rank. So let's say we are having two records with the same value. Okay, so it will assign 1 1 for both of them, and while assigning the next record, it will assign the 3. Okay, when we run the query, we will see that with example. Okay, so you will get an understanding. Dense rank, again same, similar to the rank, but it will not skip the rank numbers. It will like assigning the sequential values. Even if there is a tie, it will assign the same rank number, and during the next value, it will change the rank value. Okay, so these three first we will see by running the queries so that you will not get confused. Okay, so the syntax is same for all, just we need to change the function name. Okay, row number over order by
so
column name, rank over order by column name, dense rank over order by column name. Column name can be there, like order by clause can be written with descending as well. If it is not mentioned with descending, by default it is a ascending order. So wherever we are
yes,
using order by, default order is an ascending order, right? So let's say
mm,
with the same example. Okay, now here, what I'm doing is select star. Okay, and
mm,
I'm adding one more additional column where I'm calculating the row number for each of the mark. Okay,
okay.
rank for each of the mark, and dense rank for each of the marks. So order by clause is important, right? It has to
Mm-hmm.
be there whenever you are using this row number, rank, and dense rank. So I'm ordering the result based on the mark. Okay, so if I order the result based on the mark, or first I will write without any uh,
Marks.
window function. So what I will do is I'll just use the exam result as a table,
Mm-hmm.
and I'm ordering the result based on the marks descending. Okay, so what we will get here, we will get like this. Okay,
Mm-hmm.
marks descending. So this ID will be now in mismatched order because we are doing this result set. We are getting this result set based on the marks value. Okay, now see there are some duplicates as well. Like we have tie for 85 marks. Okay, we have tie for 93
Mm-hmm.
marks, 90 marks as well. Okay, now we will see the example with all of this. Okay, so I'm using row number function first. Syntax is row number over order by marks descending. Okay, and I'm giving one column name here, row number for marks. Okay, so this is every window function will create an additional column. Okay, here also we have seen when we ran this with an window functions, we got one new column, right? That is a calculated column with window functions. So same way here also, when I execute this, what I'm getting here is I'm getting a unique sequential number for each of the record present in a data set. And it is assigning a unique sequential number for each of the row. That is what the row number is. So row number definition,
So,
what it is saying?
so
Yes.
we use a select and the column which we want to do like a row number function. Am I right?
See, row number is like just to calculate the row number for each of these record. And why it is used is this is used for finding the duplicates. Okay, finding second highest salary, third highest salary. So that kind of calculations we can do using these window functions.
Oh, okay.
Now I'm
Okay.
asking about the sequence of query, like
Yeah, you
syntax of
can
query.
use this. You can use this as a first column as well. It is not like it should be used as a last.
Okay.
Okay, you can use any specific columns in the select list as well. Let's say you don't want all the records or all the columns. Okay, so what you can do is you can just write the query like select. I want only student ID. Okay, then I want student name. I want marks and then a row number based on the marks. Okay, so a row number based on the marks. So only those columns also can be written in the result set. We see
I
here
think
on the okay, if you want to find out now the duplicate records based on the marks, okay, so you can use this into the where clause, this column, okay, to find out those marks as a duplicate marks. Okay, so we will see the examples how to find out these duplicate records using the window functions. But currently, just remember, row number function is assigning a unique sequential number to each row within the data set. Okay. Now we know that in this table, we have one more column called subject. Okay, we have one more column called subject. So we see here, we are having this subject. So now what I need to calculate is who is the topper in mathematics, who is the topper in science, who is the topper in English. Okay. So this, what it will give it will give you the topper in all the subjects, the current query. Okay. The maximum marks, who like whatever the maximum marks we are having, irrespective of what subject it is coming as a rank number 1 for that record. Because we are not partitioning this result, we are looking the marks in the descending order for entire table data. Okay, so you will be getting this as a first record. Okay, for the mathematics subject. What I want is I want to see the toppers in each of the subject. Okay, so each of the subject I want to see the top one student. So what I can use is we can use the group by the partition by clause here. Okay, to partition the result set, partition by. Now for by which column you want to do the partition? By subject. I want to do the partition here. I will use the square bracket here because this is an SQL keyword, so it is coming in blue, so it might make the confusion. Okay, so partition by column name, then order by marks. Now you see here, we are getting 1 to 13 as a rank. But when we use the partition, so now the ranks like 1 to 3 will be calculated within each of the partition with the subject name. Okay, so English, we are getting 1 to 3. Then second partition is mathematics. Again, it is starting with 1, 2, 3, 4, 5. Third is in science. Again, it is starting with 1, 2, 3, 4, 5. So now it has created the partition, and within the partition, it is assigning a unique sequential number for each row. Within the partition, it is assigning the unique sequential number for each row. Okay, so when we are not using partition by, it will consider the entire table data as a one set, and it will assign a unique sequential rank for each of these record. When we use the partition by clause, it is like partitioning the result with respect to that column value. So there are three column values we are having. So it is partitioning the result in three different groups. And within each of the group, it is giving the, it is assigning the unique sequential number for each of the row. Right?
Mhm.
Yeah.
So let's say now your ask was just to find out the students who are the topper in each of the subject. Now how to calculate, how to find out those?
Using ranks only.
Where
Right.
row,
So we
row
can use the
number.
where clause here. Okay. Now we are having this query here. So we can simply use select. I will use star. Okay. And for the from, I will make this whatever the result we are having, this as an derived table. Okay. Give some name as a T. And I can use the where clause where now we can use this column into the where clause where is equal to 1. Right? So whatever the result we are getting from this query, this we are storing as a derived table.
Mm-hmm.
Okay, and from that we are filtering the data where row number is equal to 1, because we know like row number 1 is having the maximum marks because we are ordering the result based on the descending. So highest mark will always get the first row number. So we'll get the topper in each of the subject. Right? Now
Sorry,
there even
can you
yes,
explain this one more time, please?
right. Okay, so let's say we are looking into the row number. So row number function, what it will do, the definition is row number will assign a unique sequential number to each record into the data set. Okay, it will assign a unique sequential number to each of the row. Now, the syntax is row number over order by and column name. Okay, so this is the syntax we are having, row number over order by column name we have to mention. Okay, so we have seen this example. We are writing the query against this exam result database, and we are just finding out additional column we are taking here just to find out the we can say the row number based on the marks. Okay, for each of the row. So we are finding based on the marks descending. So we will get the highest marks as a row number 1, then second highest as a 2, 3, 4. Okay, even if the marks are same, you see here it is assigning a different value here. Okay, why? Because this is the definition, or we can say the characteristics of this row number. It will assign a unique sequential number for each record, no matter whether it is having the same marks or same salary. So in fact, whether it is having the same value as well, still it will assign a unique sequential number for each of the row. Okay, so even though we are having the same marks here, we are getting the different row number for each of the record here. Okay, even for this as well. So this is for entire table data. Now let's say you want to find out based on the subject. So within the mathematics, okay, who are the like whatever the students we are having, I need to calculate the rank for or the row number for each of the record for the mathematics students, for the science students, for the English students. So we can use the partition by clause along with the order by clause. So partition by clause will uh, divide your result into the partitions based on the column name, column values. So I'm partitioning the result by the subject, ordering by the marks. So we will get the data like this. So within each of the subject, we will be assigning a unique sequential number. Mathematics 1, 2, 3, 4, 5. Science 1, 2, 3, 4, 5. Okay. Now, when you want to see the only toppers, like who has been scored the highest mark within each of the subject. So like highest marks within each subject. So English rank number one, mathematics rank number one, science rank number one. So that we are doing here. We are storing this result into the temporary or the derived table called a T, and we are filtering where row number based on the marks is equal to 1. So we will get only the toppers. But there is an issue with this row number, as it will assign a unique sequential number for each of the record. We may not get the accurate result. Okay, you can see that with this example here. Even the this Alice Johnson has scored 93 marks, and both are having 93. That means those two students should be topper in the science, right?
Mhm.
But with this query, what we are getting, we'll be getting only one student. Okay. Why? Because even though marks are same, it is assigning a different row number for each of them. So second 93 is getting 2 here. Okay.
How
So
does it decide like which order? So for Alice Johnson and Ella, how does it decide which one gets to be one and which one gets to be two? Is it like the order it's in the table? Is that how it decides it?
uh it is like science we are having. No, it is decided by SQL only how it is deciding, because student ID is 5 and it is having 1. So ideally, if it is going with the order by clause based on the name, so it should be coming this as a first order, but it is coming for the ELA. Okay, so it is tie on the marks. It is not looking
Mhm.
for any other. Okay, let me check how it is stored in the table. I think LIC is the first stored. Where is the query? Okay, here it is. Okay, so it is stored alias in the first record. So still we are getting this as a first rank and this is as a second row number. So that is what we are getting. So we're not sure how it is coming, but if even though if it is tie, it is getting the different row numbers for those. And that is the reason we are not getting the second student who is having same marks in the science, okay, as a topper.
Okay.
It's not getting into the result set. Okay, so that thing we can uh, change using the rank function, because rank what it will do. So rank will assign a rank to the rows. Again, it will assign a unique sequential number to the each rows. And if there is a tie, same rank is assigned. Okay. And the next rank is skipped. But again, this is an issue with the rank. Okay. So for the same, for the tie records, it will assign the same rank, but the next rank will be skipped out there. Let's see how it is. So I'll be using here now a rank function. So this is a rank. Now you see here, when I use the rank, okay, we are getting a rank. Now there is no partition by clause. Okay, we are looking for entire table data. The first example, we are looking for the entire table data. And I will just mention this as a rank marks. Okay, so highest marks, it is having a rank as a 1. Okay, then second highest marks like 93, it is having the rank as a 2. And you see here, now again there is one more 93 marks we are having for ELA. Okay, so we are getting the same rank number because marks are same. Okay, but as the definition says, when it is having the same values, it will assign the same rank, and during the next assigning the next rank, while assigning the next rank, it will skip the that rank value. So there is one record which is having the same value. So 3, it will be skipped, and for the next record, it will assign a 4 as a value. Okay, again, we are having 3 records with the same marks 90. So it will assign the same rank number for all of them. But while assigning the next, again, it will skip. Now it was 4, 5, 6 will be skipped. And for the next, it will be assigning as a 7. So even rank also, it will be like quite challenging to use the rank function as well for calculating this kind of a result. Okay, we will see now using this rank function how we can calculate using partition. Now, instead of row, I will just use the rank function here, partitioning by the subject order by the marks. Okay, so for the toppers, we will get all the records. Okay, so it is having the tied marks. Okay, but the rank number will be assigned as a one only. Why? Because that is the definition of the rank. If there is tie marks we are having, it will assign the same
Same
rank
rank.
number. Right. So for the topper we got here, but what about the second or third toppers? Okay, so if you see the second topper here, okay, so there should be some second topper in science, right? This is the first topper, right? This is a topper we can say, and the second, like we can say that based on the marks, there should be someone who is having scored second highest marks, right? But we don't see anyone here because the Danes rank, that is the definition. If it is having tie, it will skip that number and it will assign the next rank here. So if I use 2 here, we will not get anyone from the English subject. Oh, sorry, wait. Which subject? Science
Science.
subject. Okay. We will not get anyone from the science here.
In real life, other than this example, where can we use this rank then? Because
Yes. So in
Mhm.
real life, we use these for calculating the duplicates. Okay. Like uh, duplicate calculation, delete duplicate values, or maybe finding out the ranking values as well. Like you want to see the, let's say you are working with some logistic related database. Okay. And you want to find out the latest container by product, or let's say latest order by product. Okay, so you can use this rank function, like, or you say like there is an customer table and you want to see the customer with the latest order, or we can say the customer with the first order, customer along with its first order and all. Okay, or we can say the customer with like more than one orders, like that. So all those we can do using the rank functions easily rather than doing with the subqueries.
Even
Okay,
Dennis would
so
be more useful for that example as well.
right. So running totals, like finding out the rank based on the result based on the ranks and all, we can use this one. Okay, I
Okay.
was mentioning you. Okay, before that we will see first a dense rank and then we'll talk about that next thing. Okay, so rank, what it will do? The difference between row number and rank is row
Mhm.
number will assign a unique sequential number for each record present in a partition, right? And rank will assign a rank number for each of the record in the partition. If there is a tie, it will assign the same rank number and it will skip the next value for the next row, right? So if it is tie, it will skip that record and it will assign the next value. Now dense rank is there. It is again similar to the rank function. Only difference is it will not skip any rank
Right.
values. Okay, so this is the most useful function for finding out the duplicates, the second highest, third highest, fourth highest, or maybe topper, second topper, third topper. All those questions we can solve using dense rank easily.
Mhm.
Okay, so if you see the dense rank, I'm running this for the entire set of data, table data. You can see here now it is assigning the rank number one for. I'll change this column name so we can understand dense rank. Okay, so now it is assigning a dense rank as a 1 for the subject, for the marks having highest mark 95. Second marks we are having 93. There is a tie. It is assigned the same rank number. Then third next we are having 90 marks. It is assigned the same rank number. And you see here, it is not skip the value in between, right?
Mhm.
But if it is a rank function, it will skip the 2 here. It will skip the 3 and it will assign a 4 to the record. Okay.
Mhm.
So that thing will be taken care here in the dense rank. I will show you all together so you will see the result. So I'm using dense rank. I'll use rank here and I will use row number. So I'm using all those three columns. And we will see the difference here now. Okay, so there are three columns I have calculated for row number, rank, and dense rank. Okay, you see here for row number, it is assigning a unique sequential number for each record present in a partition. Okay, now partition is entire table because we have not specified any specific column for the partition. So entire table is one partition, and within that table, whatever number of rows we are having, it is assigning a unique sequential number. Now second is a dense rank, second is the rank. So in rank, what is happening? Again, it is assigning a rank number for each of the record. Okay. And if there is a tie, based on the marks we are doing, if it is tie, okay, it is assigning a same rank number. But while assigning the next rank, it is skipping the rows that is having with the duplicate, or we can say the same rank number. So it is having 2 and 2. So it should, like 3 is skipped here for the next record, and it is assigned as a 4. Then again, we are having 5, 6 is skipped, and for the next record, it is 7 because these three are the having same value. So same rank is assigned here. And dense rank, okay, it is also assigning a rank number to each of the record. If tie is present, it will assign a same rank value. And while assigning the next rank, it does not skip any number in between. Okay, so dense rank is most useful to find out the accurate data. So with this example, if you go, we were not getting the record for this science, right? When we were using rank here. But if you use the dense rank, we will get all the records in entire subject. We were having the second highest marks. Okay, so
So
we're getting
quick
this here.
question, sir. What is the use case of row rank? I'm sorry, rank again. You mentioned something about containers. What is the use case for it in real life?
All right. So let's say you want to delete the duplicate records. Okay. So mostly we use the dense rank in real time. Okay, because for rank calculation, I'm saying, like if you want to second highest, third highest, latest, or like latest record, or maybe the first record. So all those we use mostly dense rank as a function. But for duplicate calculation, we use the row number function. Okay. So row number function we use for the duplicate calculations because it will be assigning the same rank, the unique ranks for each of the record. So if you want to remove the duplicate records or identify the duplicate records, you can use this row number function. How we can use is, like, let's say,
Not the row number function. I'm talking about the rank function.
a rank function you are saying. Okay, yeah, that is what I mentioned. So instead of rank, we always use the dense rank mostly. So in real time, we may not have the much use of this rank function because it is keeping one value in between, right? If there is a tie, so we will
Yes.
not get the proper results. That's the reason rank is not much used. Okay, but dense rank is preferred for all the calculations.
Okay. So there's really not much use case of rank. It's just for information we're learning.
Right.
Okay.
Correct.
Sounds good.
Okay, so these are the three functions which we use for calculating the row number or like rank and all. Okay, so now we will see some more examples on these three first. We were having the question on finding the second highest salary, right?
Yeah.
We were having the question like finding out the second highest salary. So we have this, and we have seen like to find out the highest salary, what we use is we use the max function, right? Where
Yeah.
salary greater than, or we can say less than, select max of salary from employee data. Okay, so with this, we were calculating the record having the second highest salary. With this, we were using the top one,
Top one.
right? So we're getting the, sorry, something is messy here. Max of salary. Salary not in, we can say. How to calculate the like second highest salary, employee with the second highest salary?
Salary
Salary is
we used to
less than
So with this, what we will get is the employee with the
maximum salary, and then
maximum salary. If I write this equal to here, salary is equal to, what we will get is employee with the maximum salary, employee details with the max salary. Okay, if I want to see the employee with the second highest salary,
top
order by
one,
order
and
by.
then we will
Can we use like not in?
I think we need order by.
order by
by
salary descending,
ending.
right? Where salary is less than the maximum salary.
Maximum salary, yeah.
Okay, we are
Top
getting
one.
all these records. We can use the top one here.
Top one, yeah.
Okay, so we'll get the second highest salaried employee.
Yeah.
Okay, the same thing you can do using the Danes rank function as well. Right, what we need to do is select from. Okay, I will use like, let's say employee data. This is the table we are having. So employee ID. Employee name. We have salary. Okay, and I will just calculate the Danes rank for each of the salary over. What is the clause we are having? Order by
Salary.
salary descending. Okay, as we'll say like highest salary. Okay, so with this, what we will get is we will get the salary in descending order. Now, what you want is you want to find out the second highest salary, third highest salary, whatever it is. So what you will use, just use this table in the derived table format. Okay, take this in between so it will be easier to read. Give some alias name, and then you use here where whatever the column name we are having, or we can say the some other different column name, rank salary something. Okay, use this column name here. If it is 1 or 2 or 3, whatever number of like third highest salary, fourth highest salary we want, you just need to specify this. So this will give you the third highest salaried employee. Okay, if you change this to 1 or 2, you will get this as a highest salaried employee. Okay, if you change this to 4, you'll get the employee with the fourth highest salary. Okay, why to use the Danes rank only? Why not to use the row number or rank function?
Because
So if you use the row number, it will assign a unique sequential number, right? So even if there is like match or tie in the salary we are having, like we have some records. Okay, we don't have records having the same salary here. So it will not impact using either row number or rank as well. But if it is having any tie, let's say you are having some employees with the same salary, so you will not get the accurate result in that case. Okay, so that's the reason we use the Danes rank to calculate the second highest, third highest, maximum salary and all. We use the Danes rank functions only. Okay. Now, let's say you want this employee having second highest salary within each department. What you will do? Because this is for entire table set. Okay. Now you want to find out the employees like for each department. Second highest salaried employee. So we use the partition by clause here. Partition by. Okay, and I want to partition by the department. Let's say department name. So I can use the join here. Join dbo.departments d on e dot department id is equal to d dot department id. And now I have to use the partition by clause from the d dot
Department ID.
department name column.
Name. Yeah. Okay.
Okay, so we can use here like second highest salary within each department. So we will get this record here. Okay, let's say you want to see the department name as well. So you can add this column into the select list. So we can know like this employee is from which department.
Mm-hmm.
So partition by basically used for partitioning the records with a specific column or with a specific set of data. Okay.
Mm-hmm. Mm.
Okay, I'm just sharing this table with you just to write some queries from this rank, dense rank, and row number function. I'm sharing this table into the Telegram. Okay, whether you are able to run that queries.
What? Can you repeat that again?
Okay.
You say what? Can you repeat that again?
No, did you try to run the queries using row number, rank, dense rank for the
Yeah,
exam
yeah, yeah.
result table?
Yeah, I did. I did.
Okay. Okay, now I was talking about finding the duplicates. Okay, so I was having one of the tables, so I was just added one of the duplicate records into this table. Okay, so how to find the duplicates using these ranking functions or window functions we call. Okay,
Mm.
so these are the records we are having into the table, and we see there are some duplicate product names we are having
Okay.
within the same category. We are having the duplicate product names. So we want to find out the duplicate records based on the product name. So if there are like duplicate product names, we want to find out the only those records who are having duplicates. So how to find out that? So we can do that using the row number function. Okay, because row number, it will assign a unique sequential number for each of the record, right? So we can easily use that. So I will use star just for all the columns, and then we'll use the row number function.
Mm-hmm.
Row number. Okay. Over and partition by, I will say. Partition by is important whenever you are partitioning the result or you are finding the duplicate. You have to partition the result based on some what you say based on some column. On which column you have to find out the duplicate, that column name should be there here in the partition by clause. So order by, we can use any column in the order by clause. You can just use the product ID.
Mm-hmm.
Okay, and yeah, that's it. I'll just say RN for this column name.
Mm-hmm.
And with this, you will get a row number for each of the record within the partition. Okay, so you see here a record number like product, we are getting different number here. So other are the unique products, so we are getting unique row number only. So wherever there is a duplicate, we will get other than rank number 1. So if you have to find out the duplicates, you just need to write a query like select star from, and then we just write this here, give some name here, let's say dup check as a table name, and you can write where RN is greater than 1. So no matter how many records we are having duplicate, like
Okay.
third, fourth, fifth, okay, 4 records you are having, so you will get for this laptop product, you will get, let's say we are having 4 duplicate records, so you will get the row number as a 3, 4, 5 like that. Okay, so all those will be duplicates. You have to keep only one, and other other you have to delete that. So you can use this query. Okay, so these are the duplicate records. So one record will be still there, which is having RN equal to 1. Okay, so keeping unique records, you can delete the remaining duplicated records. Okay, now to delete that, what you can do, instead of select, you can write the delete query. Delete from. Okay, now delete from will not be working here. So you just need to write delete check from, then it will work out here. So instead of delete, if you select, if you write delete, it will delete the duplicate record from the table. So there are two questions on this. Either the interviewer will ask you to write a query to find the duplicate, or
Mhm.
interviewer will ask you to write a query to delete the duplicate, keeping one unique record from the table. So if they want to keep one record, you will use RN is greater than 1. Okay. And if you like, if they say simply delete all the records, okay, by like removing all the duplicate values as well. So you just need to see, you have to delete all those products wherever there is RN is greater than 1. So you need to modify this query a little bit. Delete from this table where you can use product ID. What you can use here. So we don't want to keep the record ID, record number 1 as well. Like we have to delete entire thing. I mean, this laptop entirely, not a single record I want to keep. I want to delete both those records and I want to reinsert that. So
So
in that
mean
case,
laptop, you want to delete the laptop, product name laptop?
yeah, laptop as well as t-shirt, because those are the duplicates. Okay, so with this query, what will happen? It will delete only one record from this, like the duplicated record. The second record it will delete.
So we need to
Right?
remove these where Rn is greater than 1.
Yeah, with where RN greater than 1, it will delete only the duplicate records.
So if we remove this one, then
Yeah, there will not be any duplicate, right? It will have only one entry for laptop, one entry for t-shirt. The second entry will be deleted.
yeah.
Or we can write Rn is equal to 2 also, right?
Yeah,
Sir,
not just to 2.
if
Okay, why we are using greater than 1 is because we are not sure how many records we are having as a duplicate. Let's say more entries there for the laptop. So it will be like row number 3, right? So if you delete only row number equal to 2, okay, still there will be one
sir,
duplicate record
once
present.
again, if you are doing a partition by product name, am I right?
Mhm.
And what about the product ID?
See, that is an identity column we are having. So it is having a different
Yeah,
product ID.
but you're adding order by product ID, am I right? It is not a duplicate there.
It is a duplicate, right?
You are
Because based
doing
on
a
the name,
product
based
name,
on
it
the
has a
name,
duplicate.
right? That is what I want to identify the duplicate based on product name.
But it has a different entity, am I right? For each
I don't.
row and for each quantity, like a product code, it has a EL1001 and
That is
1002.
correct. Okay, with
It
this
is a
data set,
different product
correct,
code
correct.
with
Okay,
a
different
product
product
different
code.
product
The
ID, but
question is, I
the
know
product
this is
name
not
is
a
a
duplicate.
similar.
That is what I was asking. I want to delete based on only the product name. If product name is duplicate, this is just as an example I am giving you. Okay. If you want to find the actual duplicate, you have to write all these 3 columns into the partition by clause.
Yeah. So you are
Okay.
applying only the product name. So
Product name here.
how it gonna be decide whether product code 1 or 2 is a duplicate?
See, normally when we have this duplicate, right? So all these column value will have the same record, same values. Okay. Normally when we have the duplicate record, all these values will be same. Here we have the duplicate. Here we have the different values, but that will not be the case in real data set. When the record is
Okay.
duplicate, it will have all the same values.
But we study about the constant, like a product ID is a primary key. Am I right?
Right.
In that case, sir, here if we do row number partition by the product name, then which ID gonna be it remove? It's a 2 or 3?
Based on the order by product ID we have taken, so it will remove the 3 because based on the product ID we have taken, so we have not mentioned the descending here. So by default it is ascending. So for the first product ID in the ascending order, it will assign the rank number as a 1. 1002. It will be assigned as a 1. Then 3 it will
And
be
then
assigned as a 2.
2. Okay.
Yeah,
And then we
because
are removing the greater than 1.
right.
Okay. Got it. So it 103 gonna be removed.
Removed.
Okay. Okay, sir.
Okay, so yeah, like this we can use the query to delete the duplicate records from the table or finding the duplicate records from the table. Both we can figure it out there. Okay, I was created one more data set here, sales order. We will just see some of the examples using row rank and dense rank. Okay, how we can calculate or what can be the questions on this. Okay, now there are some sales data we are having. Okay, we have the customer name like Flipkart, Amazon, Reliance, Tata, Infosys, and all. Okay, we have the region in which that order is being placed. We have the product category, like what is the category of that product. That information we are having. Okay, so let's say we want to find out the what we can say here is we want to find out the uh, like highest the order with highest order amount, okay, in each region. What we can do, how we can write the query. I want to find out order with highest order amount within each region. What should be the query?
So partition by region and then
Select from sales orders. Okay, so there are almost 50 records we are having, and we want there are how many regions we are having? We have almost 4 regions. So within each region, there should be only one record should be coming into our result sheet. Okay, so I would say star instead of all the column names. And what should we use with the row rank, dense rank?
1 to highest order. So dense rank.
Okay, dense rank over
partition by the region. Partition by region.
Partition by region.
And order by order amount.
What should be the column used in the order by?
Order amount. What is the highest order? Highest order means max? Oh no. Order amount and then descending. Can we do it like that?
Right. So we want to find out the order with highest order amount. So order amount should be there in the order by clause with the descending clause because we want to find out the top like top order with highest order like highest amount. Okay. So we'll just say like this as an RN something column name. Okay. Now we can simply write the query to get the record from this derived table. Give some name as orders where Rn is equal to 1, right? So within each of this region, we will get the order with maximum order amount. Okay, east, north, west, and south. Okay, there is one order we are getting. Okay, like 2 orders we are getting for the East region, because order amount is same for both of these orders. Okay, so there are two orders with the same order amount, which is having the maximum order amount from this East region. So we'll be getting both of them. Okay, if we were using here row or dense rank, we sorry, row or rank, we may not get. Okay, rank we will get, but for the row number we may not get the second order here, because
Mm.
it might assign the same sequential, like different sequential value for even the order amount is same. Okay, so we will not get. So we use the dense rank here to get this. Okay.
Mhm.
Now let's say we want to find out the find orders, or I will say latest orders within each category.
Category.
Find the latest order within each category.
So we have to partition by the product
So
category.
like,
Yeah.
So
partition
we have to use the partition by clause here.
And then the order, the latest order means max. We need, oh yeah,
Not max,
So
right?
there is a
Because
order
that is what we are removing
descending.
here using window
latest
functions. We
order
don't need to
means
use
the
max
date,
and
order date,
right.
yeah,
So we will use
Order
the here order
descending.
date in the
and
descending
descending.
order, and we
Yeah.
will get the like the orders which are placed latestly on this by each product. How many products we are having? Only two categories we are having in this.
Mm-hmm. Yeah.
I think only two.
There are only two categories we have. Okay. Okay. If let's say it will ask the question like find the first order, or we can say like older order, we can say the earliest order within each category, like first order within each category.
Earliest, what was the,
Descending.
isn't it the same?
Order
Will
dates
be
descending.
so we just need to remove the
Oh yeah.
descending, right? By
Descending.
default, it is
Or-
an in ascending order.
Mm-hmm.
We will get the first order here, right? So like this, we can change this and easily calculate all those things. Okay. The same question says without a rank function, how we can calculate this?
So without rank function, we can use simply the group by clause. Means if we don't want to use this window function, we can use group by, right?
Sorry, what you said?
So
Category.
if we don't want to use this window function, we can use the simple group by clause to get the data.
Right. We have to use group by along with the subquery,
Subquery.
Mm-hmm. Yeah, subquery.
right?
Mm-hmm.
So that is what it will make the difference. It will make the query simpler. Okay, these window functions, and we'll be able to get all the details in a single query. Okay, without using any like without any using any subqueries and all, we will get all the data. If we use either group by or group by with subquery, the data will be aggregated. Okay, and that is something it will uh, make the
It
difference between
also
the simple group by clause and the window functions.
isn't it also looks the subquery? This is also nested query, right?
Yeah, this is not a subquery, but yeah, this is a subquery. Okay.
Yeah, this is
But
subquery.
yeah, but
This
a group by clause, right? If we will not get the data in this way, let's say if you are using the group by clause, what you will get here, select product category.
mm-hmm. Product category. And then, oh, order by, yeah, we are not able to
Right. So product category will be getting and minimum of
minimum of
order date.
Order
the
date.
data would be the different, yeah.
Okay. Minimum of order date group by
Group by product category.
product category. So we'll get the first order. Okay, like first, like 5th of Jan and 10th of Jan. Okay, same we are getting here as well. Okay, 5th of Jan and 10th of Jan. But I want all these details as well. What is the order ID? What is the customer and
Yeah.
all? That we cannot get here. If we add those columns into the group by clause, your answer will be different,
Yeah.
right?
We have
So for that, again, you need to write the query something here. Select maybe what is this here? What we are getting? What a category we are getting, right?
mhm,
What we can write? Select star from.
these.
But again, you will be having two results set here. Let's say I'll just use this one. Let's see whether we'll be able to get the answer using this. Where order date in
minimum date. Yeah.
yeah, we'll be getting the answer.
Mhm.
So both of these should give the same answer, right? Okay. So you have to write the queries in this way, but the dense rank will be able to get the answers or the all the columns along with the aggregated data as well. Okay.
Okay.
So yeah, what I'll do is I'll share this table as well, so you can just practice on some of the questions, create some questions based on yourself, and try to solve the questions as well on yourself. Okay.
Okay.
On this, I'll share this table as well for you along with the data. You can just create and insert the data and run the queries.
Okay.
Okay. Some remaining window functions we will see tomorrow. There are many more functions we are having, like yeah, we have the entire lead lag, then first value, last value, and we have seen like average, sum, max. So those function along with the override clause. So those all we will see in the tomorrow's session. Okay, but for the function perspective, these are the three important window functions we are having: row number, rank, dense rank. The question will be from these functions only in the interviews. Okay.
Okay. Yeah.
Yeah, I'll
Thank you.
share all these notes and all along with the data sets. So yeah, practice on it. Okay. Thank you all. Peace. See you tomorrow.